Hello, welcome to Grafana LGTM Stack course. My name is Mohammad and I'm very happy and excited for this course because I think sharing knowledge can be absolutely useful and valuable for all the people across the world. Therefore, I'm here to help you to learn this stack, this amazing stack. Absolutely, you can use other solutions as well if you want for monitoring and logging solutions. Such as Prometheus or Elasticsearch or any other tools. But LGTM, Grafana LGTM Stack can be your choice as well. I need your supporting in this course. I need your comments, views, likes, contributions, and so on. It means a lot to me and it can help us a lot to create new courses in the future, okay? So thank you very much. Let's go to the course. As you can see in this picture, we have 4 different letters, LGTM. But what are them? Let's go here. We have 4 different letters. The first letter is Loki. Loki is used for logging. It can be used as a logging solution. It means that you can push your logs into Loki, you can store your logs within Grafana Loki, and it can be used as a logging solution. Absolutely, you can use other solutions as well, such as Elasticsearch, but Loki can be your choice as well. The second letter here is Grafana. Grafana is just a visualization tool. It can be connected with many different types of data sources, and it can visualize logs as well as traces, metrics, database queries, for example, and so on. So it can use to visualize your data. The third letter here is Tempo. It can be used as a tracing backend solution. It can receive many different traces from many different sources. And finally, you can connect Tempo to Grafana as a data source to visualize the traces of your application. Tempo is one of the parts I'm going to cover in this course, okay? So don't worry about it. The fourth letter here is Mimir. Mimir is a metrics backend solution. It can be used in 2 different ways. The first way is using Mimir with Prometheus. It means that Mimir can be used as a long-term storage for Prometheus, and Prometheus can write remotely into Mimir. Or you can use Mimir without Prometheus. It means that you can push your metrics directly to Grafana Mimir. And it's amazing. And this is also one of the parts I'm going to cover in this course. Very good. In this course, we have 3 different parts. The first part is Grafana plus Grafana Agent plus Grafana Loki. It means that the first scenario of this course is connecting different types of logs using Grafana Agent and push all of them to Grafana Loki. Finally, we need a visualization tool to visualize our logs. Therefore, I'm gonna connect Grafana with Grafana Loki to visualize our logs, okay? As you probably know, Grafana Agent is a collector tool. I think it's very, very powerful because it can collect many different types of data. It can collect logs as well as metrics and also traces. And so I'm gonna use Grafana Agent here to collect different types of data, okay? The second part of this course is Grafana Agent, and Mimir. I'm going to use Mimir instead of Loki. It means that I'm gonna collect metrics instead of logs, and Grafana Agent is going to push all the metrics directly to Grafana Mimir, and also I'm gonna connect Grafana with Grafana Mimir to visualize our metrics. As you probably know, Grafana Mimir is compatible with PromQL. It means that you can query against metrics which are available in Mimir using PromQL. And PromQL is a dedicated query language for Prometheus, but it can be used for Grafana Mimir as well. And the query language of Loki here is LogQL. So if you want to query against log lines, you can use a LogQL. This is a dedicated query language for Grafana Loki, okay? And the last part of this course is Grafana Tempo. I'm going to use Tempo instead of Mimir or Loki, It means that I'm gonna create a sample application and extract the traces of that application using Grafana agent and push those traces to Grafana tempo. And here I'm gonna visualize the traces of my application. Therefore, I can connect Grafana with Grafana tempo to visualize the traces of my application. This is the last part of this course. So we have 3 different scenarios for this course. Okay. First of all, let's start with Grafana Loki. First of all, I'm gonna dive deeper into the architecture of Loki, its components, its configurations, its features as well. And then we will start collecting logs using Grafana agent and push them to Loki, okay? First of all, let's start with the architecture of Grafana Loki here. The most important thing, the most important concept you should be familiar first is index and chunk. So whenever I'm talking about index, it doesn't mean the content of log. It just means about the metadata of logs and also the key value pairs related to logs, the labels related to logs. And index can help you a lot to find your logs. So whenever you want to run queries against your log lines, index can help you a lot to find your logs because it includes the metadata and key value pairs and labels of your logs, okay? So it's very light. The next important thing is chunk. Chunk is a container for log entries and different log messages and different log entries will be added to a chunk, okay? So whenever I'm talking about the chunk, I'm talking about the content of our logs, the log messages, the log entries, and so on, okay? This diagram is so important. Please pay attention here. The first example here, we have a log message, we have a log entry. For example, printing is not supported by this printer. This is a log message. This is a log entry, okay? This log message has 3 different key value pairs, has 3 different labels, component, location, and level is error, okay? And this key value pairs generates an stream ID, okay? And also, we have 2 additional log messages here, out of paper and too much paper. These are 2 additional log messages. But the most important thing here is that they have the same key value pairs. They have the same labels, okay? Component is printer, location is the same, level is the same, okay? The log messages are different, but the key value pairs and the labels are the same. It means that whenever I have different log messages, but they have the same labels, all of them will be added to the same chunk. Okay? It's so important. We have different log messages with the same labels, so they're gonna add it to the same chunk. Okay? But please pay attention to this example. We have a log message here. Consider the environment before printing this log message. But the most important thing here is the label is different. The level is info instead of error. It means that it generates a new stream ID, and this log message and this log stream will be added to a different chunk because it generates a new stream ID because it has different labels. It has different key value pairs. The level is info instead of error. So it will gonna add it to a different chunk. Okay? Whenever I'm talking about a stream, I mean a set of logs. Okay? So whenever I'm talking about log stream, it means a set of logs. Let's go back to this picture. This picture is so important. Please pay attention here. Grafana Loki has a microservice-based architecture. It means that it has some components which are working together. And Loki has decided to separate it through different paths. Write path and read path. Write path means you're gonna push your logs into a Loki's instance. And read path means you're gonna run your queries against the log lines are available in your Loki's instance, okay? So whenever you wanna push your logs into Loki's instance, distributor and ingester are the components which will be involved to do your request. It means that distributor and ingester are the components related to write path, okay? And whenever you want to run queries against your log lines, query frontend and querier are the components will be involved to do your request. So these are the components related to read path, okay? First of all, let's start with the write path. So whenever you request, for example, an HTTP post request to push your logs into your Loki's instance, distributor will receive your log stream, will receive your HTTP post request, okay? First of all, it validates your log stream, I mean a set of logs. And finally, it will send your log stream to ingester. Ingester can append a log stream to the same chunk, or it can add the log stream to a newly created chunk. If the log stream has the same key value pairs, has the same labels with the previous, for example, a log stream, it can be added to an existing chunk. Or if we have a log stream with different key value pairs, with different labels, it can be added to a newly created chunk. Okay? So it can append to an existing chunk, or it can add it to a newly created chunk. Okay? The next responsibility of ingester is shipping and sending indices and chunks to an object storage. Actually, we need a place to store our indices, to store our chunks. And this place can be the local path, the local file system of your node, of your Loki's node, or it can be a place such as AWS S3 bucket, Minayo bucket, and GCP, and so on. And the recommended way is using an object storage such as S3, such as Minayo or GCP. And in this course, I'm gonna use Minayo buckets. So ingester will send indices and chunks, both of them, to an object storage such as Minayo, okay? So ingester has two important responsibilities: adding or appending log stream to chunk, and also shipping data to an object storage. And the read path. So whenever you want to run a query against your log lines, query frontend will receive your request, and it splits your query to multiple subqueries, and querier will receive those multiple subqueries, and it can fetch your query. It can fetch the needed data from both ingester and object storage. Okay, it can query against ingester. It can query against object storage to fetch the needed data, and the final result will be responded to the client. Okay. So this is the architecture of Loki. And also we have a component here called compactor, and it means that its responsibility is downloading index files from object storage, merge them into a single file, and upload that single file into object storage. So its responsibility is compacting index files, okay? The next component is Ruler. Ruler is a service for managing and evaluating alert expressions. You will have some conditions which you want to define some different alert expressions to notify you through different ways. So Ruler is responsible to manage and evaluate those types of alert expressions. Okay? So this is the architecture of Grafana Loki. So we need to install Loki within our Kubernetes cluster, okay? Loki can be installed within our Kubernetes cluster through two different ways. I click on Setup, Install using Helm, and we have two different ways: install monolithic Loki and install scalable Loki. What are differences between these two ways? First of all, let's click on monolithic Loki. Here we have a key word, single binary. As I said earlier, Grafana Loki has a microservice-based architecture. It has some different components of working together and so on. But monolithic way, it means that you just wanna have a single binary, and that single binary includes all the components of Loki. It means monolithic because all the components of Loki are placed into a single binary. Okay. If you want to getting started with Loki, if you want to use Loki in your test environment, monolithic can be used because this is the simplest way to install Loki, okay? But this is not recommended way to install Loki within a production environment, but it can be used in a test environment. So we'll have a single binary, and the single binary includes all the components of Loki. So whenever you want to scale your Loki's instance, you just can scale your single binary, okay? But the recommended way is using scalable mode Loki. This is the way I'm gonna install it in this course. And instead of having just one single binary, we will have three different things: read, write, and backend. The default Helm chart deploys the following components. So important. Read component will have three different replicas. Write components will have three different replicas. Backend also Loki Canary, Gateway, and also Minayo, optional. You can disable or enable it if you want. Okay. So the most important thing that if you install Loki through scalable mode, you will have different types of components which can be deployed separately, and it can help you a lot to scale your Loki's instance easier. Because, for example, if the load of your read path is more than write path, you can scale your read path separately. Or if the load of write path is more than read path, you can scale your write path separately. So it can help you a lot because you have deployed Loki through different components, and these components are working separately. So it can help you a lot. And this is the recommended way to install Loki within a Kubernetes cluster. And I'm gonna use this way. Okay. I'm gonna show you default values related to Grafana Loki's Helm chart, and after that we can customize them based on our needs. Okay. So let's open the terminal, and I want to be a sudoer, therefore I type sudo to be a sudoer, and I type Helm show values, Grafana Loki, and I redirect it to my home path. And its name will be like, for example, Loki original values.yaml. These are default values related to Grafana Loki. I open my VS Code to see these values here. Okay, these are all default values related to Grafana Loki, as you can see here. And most of them are great and suitable for all environments, all purposes, and so on. But as you know, I'm gonna use Grafana Loki for our course, for a test environment. So I can customize it based on our test environment. Or if you are using Grafana Loki for a production environment, you can customize it based on a production environment, okay? It depends on your needs. Okay, the first thing that I'm gonna show you, that I'm gonna explain here in this Helm chart is self-monitoring of Grafana Loki. So I type self-monitoring. Self-monitoring enables Grafana Loki to script its own logs. But here, as you can see here, self-monitoring is not enabled by default, it's false. So it means that Grafana Loki won't be able to script its own logs unless you set it to true, okay? But to collect logs of Grafana Loki's instance and any other applications you want, you need a collector. And as I said earlier, Grafana agent can be an ideal choice for you to collect the logs of your applications as well as your Loki's instance. Because of that, in this Helm chart, we have a section here called Grafana Agent and Install Operator. It means that you can set it to true if you want to install Grafana Agent alongside Grafana Loki. It can be a choice for you. And it will install Grafana Agent with its related custom resource definitions, such as pod logs and also log instances, for example, okay? But I prefer to leave as it is, for example, false. I'm gonna install Grafana Agent in this course as a separate tool to collect logs as well as metrics and traces and so on. So I'm not going to install it alongside Grafana Loki. It will be installed as a separate tool in this course. For the next session, you will see how to deploy Grafana Agent as an operator within a Kubernetes cluster, okay? So it will be false. So Grafana Agent won't be installed within your Kubernetes cluster by default. And self-monitoring is not enabled as well. As you know, I'm going to install Grafana Loki as a scalable mode, and it will have three main components: read, write, and backend. And each of them has three replicas by default. It means that whenever you deploy Grafana Loki within your Kubernetes cluster, each of these components will have three replicas by default. To prove that, if I search backend, for example, you will have that the number of replicas per backend component is 3, and this is true about write component as well. And it has 3 replicas by default, and also read component. It has 3 replicas by default. This value and this number is suitable for a production environment, but if you're using Loki for test environment like me, you can decrease it from 3 to 1. Okay? So I prefer to decrease this number from 3 to 1, but I highly recommend you to not modify this value if you are using Loki within a production environment. Okay? So we need to create a new file to put our key value pairs into that. So I type logs-loki as a new directory here. Let's go to this directory, and I type Loki scalable values.yaml. For example, read. The replicas will be 1. Write and back. So I decrease the number of replicas of each components here. Very good. The next thing that is so important here is persistence. As you know, each of these components, especially backend and write components, have some data that needs to persist on disk. To do that, Loki will use the storage class of your Kubernetes cluster to store the data related to these components. Okay? As you know, the value related to a storage class is null. You have to define the storage class of your Kubernetes cluster here, and Grafana Loki will use that to create PVPVCs for your components as well. So the name of the storage class of my Kubernetes cluster is, I type kubectl get storage class. You can see that I have 2 different storage classes within my Kubernetes cluster, but I prefer to use standard storage class in this course. Okay, so I can define the name of the storage class here, and Grafana Loki will use that to create PVPVCs for the data of my components. So I need to type persistence. I go to my file here, Loki scalable. For example, for read component, I type persistence, and its storage class will be standard. standard. Okay, I copy these two lines for other two components as well. For write component,
Yes. Das will ich nicht.
very good. So as you can see here, the storage class of each of these components is a standard. So Loki will use standard as a storage class to create PVCs for your components, especially for backend and write components. Okay? So it's very important to define the storage class of your Kubernetes cluster here. The next key value pair that is so important in this Helm chart is auth enabled. So I type auth enabled. This key value pair here. As you know, that value is true. If you probably know, Grafana Loki is working as a multi-tenant model. It says that the requests and data from a tenant, from a specific tenant, are isolated from other tenants. For example, the requests and data for tenant A are isolated from tenant B. So to show you how it works, I type Grafana Loki multi-tenant or multi-tenancy. This line is so important. Grafana Loki is a multi-tenant system, and the requests and data, for example, for tenant A, are isolated from tenant B. So, whenever you want to make a request to Loki API, you have to define an HTTP header within your request. And that HTTP header is X scope org ID, which identifies the tenant ID. Okay, it's required to define an HTTP header within your request whenever you want to make a request to Loki API. Okay, if auth enabled is true. But you can set auth enabled to false if you want. If you set auth enabled to false, it means that Loki uses a single tenant. So in that situation, the X scope org ID as an HTTP header is not required in Loki API requests. And the single tenant ID will be the string fake. In this course, I'm gonna set auth enable to false. It means that Loki will use a single tenant, and the tenant ID of this single tenant will be fake. The name is fake, but it's real, okay? I'm going to show you that tenant ID, I mean fake as a tenant ID, in the next session, whenever I use Minayo to store our chunks and indices, okay? You will see this tenant ID here. Okay, to set auth enable from true to false, I need to copy this line, auth enable true, and let's go to this file. And we have a new section here called Loki. And here I type auth enabled equals true. Very good. The next thing that is so important is replication factor here. Replication factor under common config block. To decrease the chance of losing data, distributor as the first step, as the first component of write path, writes to the replication factor of ingesters. For example, as you can see here, the default value of replication factor is 3. It means that distributor will write to 3 replicas of ingesters to decrease the chance of losing data. But as you saw earlier, I decreased the number of replicas of write backend to 1. So definitely I will have 1 replica of ingesters in this situation. So to prevent any new errors, I have to decrease the number of replication factor from 3 to 1. And it means that distributor will write to one replica of ingester. So, okay. I need to copy this line, common config, to our newly created file here under Loki block. Common config, and then copy this line, replication factor, very good. And I decrease the number from 3 to 1. It means that distributor will write to just one replica of ingester instead of 3 replicas, okay? And, auth enabled must be false because I don't want to use authentication here. I just want to use a single tenant ID here. So I prefer to use auth enabled to be false. Very good. I save the file. Let's go back to the architecture of Grafana Loki. I want to show you something. As you can see in this picture, we need a place to store our indices, our chunks as well. And this place can be the local file system, a local path of your Loki's node, or it can be an object storage such as Minayo, AWS S3 bucket, or GCP or something like that. Okay. In this course, I decided to run a Docker container related to Minayo to store our indices and our chunks. Okay. So I have a predefined Docker compose related to Minayo to run and start a Docker container. So I go to a directory called Minayo, and here I have a Docker compose related to Minayo container. Yeah. So I need to up and run this Docker container. I type docker compose -d. So whenever I type docker ps, you will see that we have a newly created Docker container related to Minayo, and it's up and running. Everything is good. So whenever I type ping Minayo-local, it returns the IP address of my local machine. And also I can type, for example, curl http Minayo-local and the port number of Minayo. Everything is good. So I need to copy the URL here and paste it in my browser. Very good. And this is a dashboard related to Minayo. I logged in already. Because of that, I don't need to enter my username and password once again. As you can see here, I have no buckets here, as well as access keys. I need to create a new access key and secret key. Grafana Loki needs your access key and secret key of your Minayo account to put index and chunks here. Okay, so the first thing that I'm gonna create here is access key and secret key. I click on create access key and it generates a new access key and secret key for me. Okay, I need to copy access key as well as secret key. So I type access key. The access key is this, and this is the secret key. Secret key. Very good. And everything is good. I click on create. It says that to write this down as this is the only time the secret will be displayed. Very good. Okay. This is my new access key and secret key. I can click on edit and I can set a description or set a name for it. For example, I can set a name for it such as Grafana Loki. Okay, so Grafana Loki will use this access key and secret key to put indices and chunks here. Okay, very good. Let's go back to the Helm chart related to Grafana Loki, and here we have a block, we have an important block here called storage. You can use storage block to either to define your, for example, AWS S3 bucket or Minayo bucket or something like that. Okay? A storage block is under Loki block. And the type is S3 because Minayo is S3 compatible. And we need to enter some information here. So I copy a storage from here. I go to logs Loki and Loki scalable values. And here I type storage. The type is S3. Minayo is S3 compatible. So the type will be S3. And I type S3 here as well. The endpoint. The endpoint is this, for example. Very good. The next thing that I'm gonna use it here is secret access key. The secret access key is this. Access key ID. And access key is this as well. Insecure is false, but I'm using HTTP instead of HTTPS. So I need to set it to true. It means that I'm using HTTP. Okay, so insecure is true. And S3 path style, which means that it's going to create directories and subdirectories into my bucket. Okay, so I need to set it to true. Very good. And the next thing is region. For example, here. For example, I can type EU East 1 as a region. And you can create a region for your Minayo account, something like this, configuration, click on configuration. The region is US East 1. For example, you can change it based on your needs. It depends on your needs, okay? You can change it. For example, US East 2, US is US West 1 or something like that. But my region, my current region here is US East 1. So my region here. And I think everything is working well. And okay. And also, if you are using GCS instead of S3, you can use these types of things, or Azure or Swift or something like that. Okay. But S3 buckets or Minayo is S3 compatible. You can use these types of information here. Okay. I saved the file and the next important thing here is defining the buckets. As you can see here, the bucket names here, chunks, ruler, and admin. The indices and chunks, both of them are going to be stored here in this bucket. And your alert expression, ruler configs, and so on are going to be stored in ruler bucket. Okay? So I copy this line. It must be under storage block. Very good. For example, chunks can be Loki chunks, Loki ruler, but I don't need admin bucket, so I can delete it. Okay, so very good. Everything is working well, and I save the file. The last thing that I'm gonna explain for this session is schema config. Let's go to the browser to find a schema config here. I click on configure in storage, and I'm looking for a schema config in this page. Yeah, it's here. A schema config defines index format as well as how to process and store our indices, okay? There are two different ways of using the schema config within Grafana Loki. The first way is both DB as a store or TSDB as a store. You can use each of them based on your needs, but both DB is now deprecated, and also TSDB has a better performance. And the preferred way and the recommended way is using TSDB instead of both DB as a store for a schema config. But what is TSDB? TSDB is a time series database. It's optimized for storing and processing time series data, which is data that is collected over time. And TSDBs are designed to efficiently handle large volumes of time series data and provide fast query and analysis capabilities. Okay, so I prefer to use TSDB as a store instead of both DB. So it defines the index format as well as how to process and store our indices. Okay. So first of all, I'm gonna go back to the Helm chart to find the schema config here. So I type schema config. Yeah, it's here. It's under Loki block. Okay. Let's go here and I type logs Loki and Loki scalable, and under Loki block I type schema configs. And under schema configs we have configs. Very good. And instead of both DB, I'm gonna use TSDB. So the first entry is from, for example. This is a date related to the past, not for the future. It's so important that this is a date related to the past, for example. And I need to copy these lines from here and paste them into my file. Very good. The schema is v13. And object store is S3 instead of file system. And the type chunks. And period here. Everything is good, I think. Very good. The next and the last step for this session is creating two different buckets to store our indices, our chunks, as well as ruler expressions, and so on. If you look at here, we need to create two different buckets within my Minayo account. Loki-chunks and Loki-ruler, okay? So let's go back to my Minayo account. I click on Object Browser and I can create a bucket here. The first bucket, the name of the first bucket is Loki-chunks. And the name of the second bucket will be Loki-ruler, okay? So the ruler configs or alert expressions and so on will be added to this bucket, and indices and chunks will be added to Loki-chunks bucket here. Okay, very good. So now let's install Grafana Loki within our Kubernetes cluster. I type helm install -n Loki, and the release name will be something like Loki Grafana /Loki, and the file is Loki scalable values. Okay, Grafana Loki has been installed within my Kubernetes cluster, and we have 4 different installed components: gateway, read, write, and backend. So when I type kubectl get pod-n Loki, these are all the pods related to Grafana Loki instance, okay? As you can see here, we have just one replica of Loki write and one replica of Loki backend, or one replica of Loki read, okay? As you can see here, Loki write and Loki backend are stateful set, and Loki read is a deployment. So when I type kubectl get stateful set -n Loki, these are stateful set components within Grafana Loki's namespace: Loki backend, chunks cache, result cache, and Loki write. And the deployments are these. I type kubectl get deployment -n Loki. Loki gateway and Loki read are the components related to deployments within our Kubernetes cluster. Okay. Everything is working well, and all the pods are in up and running status. And let's go back here, and as you can see here, we have a new object within my Loki-chunks bucket. This object has been uploaded by Grafana Loki, not me. And this is a JSON file, and this is the information related to our Loki's instance. And whenever we use a collector, such as Grafana agent, to collect logs and push them to Loki, Grafana Loki will try to add indices and chunks into this bucket here. And it will create some different directories and subdirectories into this bucket, okay? So everything is working well. We have using Minayo as an object storage to store our indices and our chunks as well. And also we successfully decreased the number of replicas of our components here. And so everything is working well. In the next session, I'm going to install Grafana agent as an operator, and we will start to collect the logs related to our applications and so on to our Loki's instance. And the most important thing that I'm gonna try to connect Grafana Loki to Grafana as a data source to visualize our logs. Thank you very much. Thank you very much for watching. I hope you like it, and see you soon.